Hello, everyone. Welcome to our first RoadEng and SoftTree webinar of 2024. So Happy New Year to everyone on the call. Today's topic is going to focus on road design using total station data. For those of you who don't know me, my name is Erin. I'm the Business Development Manager and our resident English webinar host. Of course, I don't cover the Spanish-speaking ones. And with me today is our training manager, Matthew Dickey. So today, as I mentioned, we're going to focus on talking about total station data. We're going to do so mostly focusing on an in-software workflow using some example total station data alongside our RoadEng software. So if you're not too familiar with it, RoadEng is a geometric civil design software. It is a standalone program, and just to let you know that there is no additional CAD platform needed. The software itself is modular, so let's just talk a little bit about the two different modules we're going to work in today. To start, we're going to be in the terrain module, and this is our module that helps us to work with our survey data. So today's example is all about total station data and defining the breaklines and building our TIN or our DTM model from that. There's lots of other webinars up on our channel. As I'm sure many of you know, we love to talk about LiDAR and high resolution data and how to use that in the software. So if you're working with that type of data, the second half of this webinar should be reasonably still applicable. The workflow is going to stay kind of the same once we get into location, but everything we're going to do in the terrain module really is very much centered on conventional survey data. Inside of the location module, which will be sort of the second part of the webinar, we're going to focus on a road design example. We're going to do a realignment, and then we're going to talk a little bit about creating output and how to export to sort of conventional means such as, slope staking information, etc. So that's, a little bit about where we're going. To start, we did want to, talk a little bit about one key piece that's not necessary in the workflow, but it certainly is nice to do. And that's this piece that kind of fits in right here, which is creating an import specification. So an import specification is something that we can set up and then reuse with our survey data. And an import specification really is a way of describing to the software how to interpret the data that you've got coming in from your survey file. So you've got, say, for example, a CSV file. It's got different columns. It's got different point codes included in it. And we can set up an import specification that tells the software how to read your typical survey data so that every time you go to bring in a new project, you've got that already set up. So a huge amount of time can be saved in working with import specifications. They're definitely reusable between projects. And as I mentioned, it includes, structural elements, for example, the different column assignments, if you've got delimiters or if you need to skip characters, all those types of things are included within the IOP. And the most powerful part of it is that it can actually start to define some of your line work automatically. So an import specification can include your different point codes and some of the different, I should say, even you can have them even coded to work for the different sides if you've got point codes that happen on either side of your road, to be able to automatically join those features to create polyline. And it can really allow you to drive a lot of consistency in terms of the colors you're working with, the different line types, the different symbology, and it makes it, really, really powerful. So before we actually get into the official workflow presentation, I'm going to pass it over to Matt. And we're just going to give you a brief introduction, a primer into understanding a little bit more about what an import specification is, how you can work with it, and how you can update it. So for that, Matt, are you with me?
I am. And,
excellent. I'm going to make you the presenter here.
Excellent. So before we get into that linear workflow of just walking through the normal steps, we're going to add a little explanation on things. So one thing that we've done previously was just a general webinar on terrain modeling. So this is going to kind of complement that, and bringing in this total station data. Well, it can be really, really easy to create a surface like this. So just to start, if I have an IOP and I click Insert File, so this being my survey data, so and of course the the title is total station data, but it could be your RTK data as well. All it is just an ASCII file, in this case, a comma separated value file. So my file has a point number coordinate, so northing, easting, elevation, and a point code. So if I bring that into my terrain file here, well, if someone recently installs the software, they're not going to have this IOP down here that's called OEL terrain. They'll have these options, but I've configured this one to do what I'd like. So with this, on the structure tab, I have my northing, so my Y coordinate set to be the second column. So this number here. I've got my easting to be the third, elevation, and the point code. And the point code is the fifth, and that's the important one. It makes it really easy for us to streamline the process and save having to connect the dots. Now, a few other things worth mentioning here. Well, it's a CSV, so it's comma separated, and there's no headers, so I don't need to skip any lines at the start. And it's XY coordinates rather than lat long. Now, that code, so this column here, and this column in our CSV is really where we can, well, leverage the functionality of the software to save a bunch of clicking around. And that's not to say that you need to do this. You can absolutely do it without an IOP or using the standard IOP. But if you're surveying lots and have common names for things that you're surveying, it really does make sense to just set this up. So we'll hit OK. And since that's set up, all those lines are generated automatically. And since all those lines are generated where we'd like and our points are generated where we'd like, when we hit generate, we've got a really nice surface without having to mess around and move things. Again, and I'll talk about it here in a moment, but that's not to say you're stuck with this. If there's a survey error or something that was named improperly or got the wrong line type, you can absolutely change that. But yeah, it really helps streamline the process. So rather than just looking at something that is already set up, I won't build the whole thing from scratch, but I will just back up and we are going to at least talk about the functionality as we build that out. So just starting out a new terrain file here to run with something that doesn't have an IOP. So here, my default settings match the default at install. We've got our ASCII text option. If I wanted to build something new and had different formats that I'd like to follow for maybe different clients, I could, or I could just modify the default setting. So I'll hit OK. Just so happens my X, Y, and Z and code are all right in this case, but my codes are left blank. So I've got default, so anything that isn't accounted for in this list, that isn't a list underneath here yet, is going to receive this formatting. So it's just going to be a point. It's going to be included in our model, and it's going to get that little black cross for a symbol. So if I don't have any formatting applied, it still works. We still have 3D points. It's just all that formatting isn't applied. And if we were to model this right off the bat, we'll talk about this more later, but if we just use those points as points without formatting, well, it's not the nicest surface. And Breaklines will be a really important tool to help us eliminate these triangles and forced triangles where we'd like them. So I don't want that triangle there, but I probably would like a triangle from here to there. We'll talk about that with breaklines. So rather than just running with the, well, an empty IOP, we can add codes in. So we can hit add, and we can add in individual codes as we like, or we can hit load and we can read in everything. Now I don't want to do that. I want to set this up a little more nuanced than just reading in all the different point codes. So I'm going to click add, and I'm going to make a new point code that is called CL. So anything in this list that has the CL code associated with it will be treated as I tell it to be. So I want it to be a polyline. I want to connect all by code. I want it to be a break line. I'll make this a red line with a circle at the vertices. We'll hit OK. And there we are. So that's the premise of this. If we add it to the list, we don't have to play connect the dots. If we set this up, and I'm going to add another code in here. So I've got some surveyed features that are called Topo bank. And one thing that I'm going to do here is I'm going to add in this little asterisk afterwards. So that asterisk is a wildcard character. So anything that is surveyed as a feature with the name TOB, whatever comes after that is captured by the wildcard. So if I have a TOB1, so Topo bank 1 feature, a Topo bank 2 feature, that lets us separate it by the code name. So we've got connect all by code. When we bring that in, we can see these TOB features. So that's surveyed there. TOB7 is separate from my TOB11. If I had have used connect all, so in this case, it's going to treat anything that starts with TOB all as the same feature. It's not going to separate my TOBs 1s, 2s, and 3s. When we bring that in, we can see we've got these lines connected that we might not want to. And once again, it's not the end of the world. We can modify it and make it do what we'd like. So in here, if I brought that in and I didn't want to just re-import the data, well, I can use a bunch of functionality to edit my line work, like break at current point. And I can go to the other end of this, break at current point, and we can split that up and work with that. So that's really the lion's share of the brunt of it. There's functionality in the software to edit your points and modify your points, change your line work, connection order. If we want to just move a point, we absolutely can. In this case here, I'm going to just invert my selection. So everything that isn't the features that I had selected, I'm going to turn the display property off so I can make it really easy to focus on a certain type of point. And in this case, I'm going to just show something that's relatively common. So break, explode. If those road edge shots were not separated by R1, R2, or some kind of identifier, terminating character maybe, if we just brought them in and joined them, it wouldn't be a surprise to get something like that. So if that's the case, if they weren't surveyed with an identifier to separate them or anything like that, it's not the end of the world. you can really quickly modify that by, well, connecting the dots individually, or in this case, I'm going to just modify break. I'm going to explode, so turn that feature into the individual points. And I can use, well, some pretty simple functionality to really quickly isolate just one side of that. So if I want to, I can click Modify, Close. I've got a polygon now around that one side. Select feature, by boundary, inside. So now it's just my road edges on that one side. And even though they weren't surveyed, and I'll put that in quotes because we made it seem like they're not surveyed, with an identifier, we can just hit Control J or right click, modify selected feature, join, and away we go. So all I'm getting at here is even if you didn't survey it, an ideal way to, well, to make it as easy as possible, you can still keep it pretty easy. Just working with the, well, tools like modify selected features to get what you like. And of course, if you wanted to move an individual vertices, you can. We can hit undo. If you wanted to do something like change an individual coordinate, we can. So if we wanted to change the height, if we surveyed this whole thing and realized our rod height was off, we could just do a quick shift. And yeah, all sorts of things we can do to modify it. And then another important concept with this is break lines. So if I have a feature like this, one of the properties when we brought that in, oh, and I don't have the standard template, where are we?
And while you look for that, Matt, I might just flash up sort of the next phase of our sort of introductory concepts here. I'm going to steal the screen for just a second.
Okay.
Yeah, so Matt kind of gave us the introduction to what the IOP file is, as well as some details around connecting points. So going back to sort of how this plays into the typical workflow. So he's in the terrain module. We're going to stay there for a few more minutes, but he's imported the total station data. And now he's going to move into the sort of next important part, which is, how do you define your break lines, as well as, the potential of fixing crossing break lines and why that's important. From there, we create our TIN model, generate contours. We can show you how you can control your contours, the interval they're at, the colors, etc. And then we save that file, and that's the extension for that is .terx, so we call it a TRX file. And then you can head over into the location module, and that's where we can actually begin our new road design process. So we'll include that topo. We're going to configure the cross-section, create our actual alignment. So there's got a whole bunch of different tools available to help you improve the process of your horizontal and vertical alignment design. We can get earthwork quantities, as well as other, add labels, lots of detail you can happen here. This is just the absolutely mandatory stuff. Create your construction drawings, and then we'll talk a little bit about output. So this is sort of the next phase of where we're going to. So that from that IOP file, we can now move into an actual workflow that you would typically expect with a project. So with that, sorry, Matt, I stole the screen. I'm going to pass it back.
No problem. All right, perfect. So I guess and I will go right back to square one before we go into that conventional workflow. But one of the options we have here is a break line. So when I brought this in, I told it that my TOBs should be treated as break lines. And well, what does that mean? If we look at this, we have this feature that has a break line property associated with it. If I turn that off and hit apply, that's no longer a break line. So when I model my surface, we can see in this case, that triangle is allowed to cross that feature. But if we had kept that as a break line, the triangle has to, it can't cross that line. So it's really nice functionality to make sure you, well, limit your crest of hills, toes of hills, etc. And like same with my ditch here. That surface is following my ditch because my ditch is set as a break line. Now, the last kind of theory thing here that I'm going to cover before we just go back and cover the normal workflow without diving into the details is, well, if we had something like, so I've just created a new feature and I did it by hitting Control F, but if you want to create new features, you can just by clicking that. So if I have a feature that goes across here, that new added break line is crossing several other break lines. And now when I model, it gives us this crossing break line warning, tells us what features the crossing break line. It'll still give us a surface, but that warning tells us that it's ambiguous. And what that is if we're telling that this feature, triangles can't cross it, and this feature, triangles can't cross it. So triangles in the triangular irregular network that we use for our surface, and there's no common point where they cross, well, it's not compatible. So if we brought in our data and we ran it and we got that warning and we wanted to make sure that we're not leaving anything to chance to have modeled wrong, we can right click, select feature by property. We can say, well, we want to see those crossing break lines. And down here, I can see I've got one feature selected. If I zoom in, the magenta features are selected feature, and that's that. The other thing I could do is I could say, well, populate my selected features over here, or populate my individual points, and I can see from this point to that point, there is a crossing break line. And of course, in this case, it's just an arbitrary line that I threw in there. We can turn the break line property off if we didn't want it to be a break line, but still want to see it, or we can just delete that feature. So, bunch of useful theory there. It's all useful. But aside from setting up your IOP once, it's usually pretty painless to run through this stuff. And with that, I will let's go back to square one here. We'll separate all the tangents and explanation from a more practical approach. So square one will go through a typical workflow, starting from an empty terrain file and working towards that final road design. So just flashing up terrain, we're going to click Insert File. We're going to grab that all topo. And darn, that IOP that I have built isn't there. Last time I was in there, I didn't save it as my default. That's fine. I can click New, and rather than building it out from scratch, I can click Open, and let's just go in here, and I'm going to open up the IOP that I already have. Now, while that thinks and loads, Open will replace everything in your list here. If someone gave you an IOP file and you wanted to add their IOPs into yours, I would go with a merge, and that just adds in anything that isn't common onto the end of the list here. So we've got that. We can see that this one's formatted the way we'd like. I'm going to assign a projection to my files, and you could save this as well, but I didn't, I just left it as undefined. So I assigned it. We've got our file here. I'm going to click Train Modeling, and I've clicked this Train Modeling button a few times without really messing around with anything. I've got my contours. I'm going to change the contours to be 10 and 2 rather than 5 and 1. If I want to change my colors for my contours, I absolutely can, except I like the default, so I'm not going to do that. And I'll change my maximum side length here as well. And all that does is limits the maximum length of our triangle edge, so we don't have long interpolations along the outside. So this is my Topo surface. I'm going to hit save, and I'm going to say Topo web, and we're set. We could jump right over into location. That's saving. I guess I shouldn't talk before it's done saving. One thing that, again, another optional item is we can use background files if we'd like. Since this is georeferenced, we can connect to our web app tile service. And we can download some imagery just for added context. And there we are. So aside from just our survey data, we can see what's actually going on. So we're done in train. I'm gonna open up location. And for those of you that are in the webinar that don't commonly use total station data, the rest of this is largely the same, regardless of what format of survey data you're using. So when I start out my location file, where in this case it's going to be a road design, a realignment project, I'm going to click New File. I'm going to browse. I'm going to make this reference the Topo file that we've just created. I'm going to just start with a single point in I'm going to click in my new alignment by hand. If we had something else that we wanted to use, we could. I'll talk about that in passing here later. And we can apply our template or just leave a default cross-section template. So I'm going to right click here, plan options. We took the time to add in that background image, so we might as well load it into location as well. We could change our cross-section geometry if we'd like. Now in this case, I'm fairly happy with just our defaults. So our cross-sections are controlled in our template editor. I'm happy with this. It's a 7-meter wide running surface with a shoulder. So I'm going to leave that as is. I'm going to right click in my plan view. I'm going to click Add Edit IP. I'm going to unanchor this IP here. I'm going to place that where I'd like to start my new road. I'm going to click outside of the snapping tolerance over here. This is where I'd like to get my realignment to. Now I'm going to zoom to extents in my profile. I can see I'm falling off the surface. I'll zoom to extents in my 3D view. Oh, I guess it doesn't like that I'm off the surface here, so let's pull that around. And so now we can see, well, that's where I've clicked in my initial horizontal alignment. I'm going to refine it. As I refine it, my profile is going to update, my cross sections are going to update, my 3D view is going to update. So it's really going to be, oh, it's going to be slick. It'll be, so we want to start out there. That's moving around. I'm going to try and keep this at, say, a 60-kilometer-hour design speed. So I'm going to add in my curves. So I can set my radius to whatever I'd like. Got super elevation being applied for me. I'm going to cycle back here. And let's see, so we want to add in another curve here. And so this line in my profile is showing the ground just, or the cross section of the ground. We of course want our road to not have all those humps on it. So right now, we can see if we just do it as the straight shot while we're doing a lot of cutting. Our mass hull shows us that we're doing a lot of cutting. Let's just manually go through and try to minimize our cuts and fills. And here I'm going to do it manually just because I think our last webinar was an optimization one. But we do have our optimization side of things that will can really speed this along, and rather than trying to get the solution that has the least amount of cuts and fills, we can actually calculate it and save construction, money for construction, and save time for design. Next here, I'm just adding in my vertical curves. And this tells me it doesn't fit. So I can't fit a K value of 16 in there. I'm going to pull this over, make a little more room for that. I'm going to pull this over. I'm going to try and add that 16 in now. It fits. I'm going to crowd that. I'm going to pull this over here. Oh, I guess I didn't finish doing my vertical curves. So there we are. We're pretty close to balancing. I can add my design totals in my data table down here so I can see what I'm up against. I've got a bit more fill than cut. Makes sense. I've got a little bit of a deficit. If I want, I can add in culverts. Now, I won't do it just because this is kind of repetitive. After, once you've seen one, you've seen all. I'll change that size though. We'll do 1,000. And then if we're happy with that, we can go over to our multi-plot. Now I could add in pre-formatted chapters from our web library. I could build something out from scratch, or in this case, I'm going to just bring in a workbook that I've already got. So kind of like our IOPs and our templates too, we don't have to reconfigure those every time. We can save things out and use them to, well, further streamline our process. So I've got my plan over profile. In this case, I'm going to just move that a bit. I've got my cross-section chapter. If I want to control how frequently I see those sections, I can do that here. I'll go every 5 meters rather than 100, but we could change that number too if we'd like. And, well, we've got a real quick document put together. If we want to export it for, well, having a digital version of this for construction staking, we can go save as. We can save it as a land XML or well, we could export a, where is it? Coordinates file, so text for stake to point, or you can export in any number of vector formats, so DWD, DXF, etc. So that's my spiel. And one thing before I open it up for questions, when I started this out this morning, I thought, well, I'm going to do an overlay and widening project. And I had this data set on hand, but it turns out it's not a great example for doing just your standard overlay and widening, just because it's a lot of work to do it. So the example doesn't really make sense, but I figured I'd flash it up, and well, we can add in different templates that do different things. So here I've got a widening template that ties the edge of my road to an existing feature rather than having an offset. So this tie feature in that Topo done file that I have referenced for my Topo, I can see all the different features names. So with that dynamic tie, this position where that widening starts is fixed, and we keep the road width that we'd like. So that's kind of one other nuance to working with total station data that's common. And another thing that is well, a new version 11 feature that we have in the works is the ability to take a vector and turn it into a proper alignment. So with taking a polyline and turning it into an alignment with curves. So I'll just quickly show that in passing here. So I'm going to add in a horizontal alignment. I'm going to, I guess I'm clicking faster than I'm talking. So add horizontal alignment. I'm going to add this in from a terrain feature. So I'm going to use that top option. So this is the same dialog that we saw when I first started this file up, and I chose to use a single point. Well, here I'm going to use a feature, and I want to use the surveyed center line. I'll just leave my default cross section for this. So we've got that, and right now, if we leave that as is, every surveyed point along that line is an IP. So the standard way to go about that would be either, well, trace it out and simplify it into just curves and tangents, or delete sections where you wanted to leave them as tangents and isolate it out. With this new version 11 feature, we can come in here, and I'm going to use polylines to alignment with curves. I'm going to say, well, let's try to get a minimum radius of 60 meters. We're going to shoot for a maximum offset of 5 meters. And in this case, well, that doesn't work. This curve is way tighter than 60 meters anyway, so it can't comply with that. But what it does do is it's going to search and try to reduce it down to as few of curves as it can, while doing its best to comply with that where it can. So it's not going to guarantee an optimal solution, but it is going to be saving a bunch of time to rather than having to trace. And it's also one of those kind of tedious jobs. So we might end up moving things around after a bit, but it's going to be a much more easier alignment than an alignment that's just a duplicate of a polyline. So there we are. And it wasn't quite able to adhere to that offset because this curve doesn't fit, but we can see it does a pretty good job of matching up with our surveyed center line and having curves. So now we don't have to move a bunch of IPs. We can just grab this and say, well, I want to move that around. And with that, that is my, I guess, my spiel, and we'll open it up for some questions.
Perfect. So just a reminder to our webinar audience, if you would like to ask a question, you just need to sort of expand that GoToWebinar panel that you've got. There's a question section. You can type your question in there, and all question askers do remain anonymous. And for those of you watching this off of YouTube in the future, you're welcome to ask us questions too. Response time's not quite as quick as a live webinar, but we will definitely respond to your question. So the first one, Matt, is it possible to import custom 2D or 3D symbols or for points? So back in the terrain modules, we were doing our import. For example, custom road signs or street lights or different types of trees.
Yeah, it is. So I guess I'll just take this guy here. So I've got some features called power poles, select features by name. So I'm going to just grab everything that's called a power pole. Now this isn't hooked up to the IOP, but you can do it pretty quick after the fact. So let's add in a transmission tower at those points. And there we are. So we've got our transmission towers. They are just a 3D symbol. You can move them around however you'd like. But yeah, there's all sorts of different 3D options that you can run with there. And so maple tree, cedar tree, and then it's always nice to just have some simple options like let's go a sphere. We'll make it big, easy to see. So my selected feature is the center line right now. Let's scale that up by a factor of 3, hit apply, and there we can see in our 3D where the vertices are a little easier. So hopefully that answers the question.
Okay. If that question asker has any further questions on the symbols, yeah, please just type it back into that panel. We'll come back to you. The next question is, can you explain the breakline definition again? I lost it.
Yep. I'm going to grab a different example. There's one that I frequently grab that I find it's a little easier to see. NS. All right, I'm going to put these side by side. All right, so, and let's, so right now in this file, if we look at our 3D model, faintly we can see these triangle outlines. Now just to make that pop a little bit more, I will turn that back on. So those are the triangles that make up this surface. And right now, no triangle edge crosses this feature at the bottom here because that feature is a break line. Now there are cases where you just want to delineate something. Maybe it's like a drip line off a tree or something like that, where you don't necessarily want to have the line work influence your surface, but you still want to be able to see where it's at in the plan view. So in this case, it makes sense for it to be a break line. If we turn that break line off and we remodel, we can see now, while those different lines line up where lines are still in the same position, but places like this, it's allowed to, the triangles that make up our surface are allowed to cross and have that interpolation from this point to that point, rather than forcing the edge from that point to that point. So really, it's just meant to delineate notable, struggle to define it without using the term, but notable changes in the topography where you can delineate that change in topography by a line to control your triangles. and just, again, turning that back on. Looks much better in this case, if that's a line, a break line. Hopefully that helped. And
Okay.
if I didn't properly answer that, let me know and I can follow up individually.
Perfect. The next question for you, Matt. Will I be able to import the model into another design software like AutoCAD Civil 3D, and will it be a working model and not just a block?
Yep. So LandXML is your friend for that stuff. So save as LandXML, name it whatever you like, and that's going to preserve the actual triangles that make up the surface. Another option, if you don't like LandXML for whatever reason, you could turn on the wire mesh. And you could export that wire mesh to define the surface in another program as a DXF. And then if you're working with something that you want more of the 3D solids type format, you can export it as an OBJ. So, yep, all sorts of compatibility.
Yeah, and I think the same holds true for exporting from the location as well. You can save your alignments out as LandXML to preserve their geometry.
Yep.
Yeah. Okay. Still lots more questions to go. So let's get through a few more here. Is there a way I can move the 3D window onto a second screen and keep the plan window on my first screen so I can see both at the same time and splitting the two?
Yeah. So short answer is yes, and this won't look great for those of you that are, well, for everyone, because I can see my other screen, but you guys can't. Basically, rather than just maximizing your window up here, we can reduce it down, make it as big as we'd like, and pull these other views over to where we'd like. And with that, if it's something that you usually like a certain layout, like I do, you can save your screen layout. So when you open the software, it looks the way you'd like. So this obviously is set up for just looking at a single screen. But if I had that spread out across multiple screens, I could save it as a screen layout. So this screen layout that I'm using here to design with, where I've got my plan here, my section here, and profile here, is not the default settings, but I've saved it as my normal.dlt. So every time I open the software, things are where I'd like, kind of like dealing with the IOP. Do it once, you don't have to mess around with it later. Things are just where you'd like them. But short answer, yeah, just drag the window across and have RoadEng on both monitors.
Excellent. A follow-up on our symbol question. So this particular user was wondering if you can import a custom symbol, not just the ones available in the list.
Sorry, I did botch answering that.
And I think we're talking about both 2D and 3D symbols.
Okay, so let's see here. General tables. We've got our symbols, so we can set up our 2D symbols and line work to be customized. We can load those off of a block. For the 3D symbols, I don't think the user has the ability to load those in, but if there's something special you'd like to see, let us know. We can probably add them in fairly easily. Yeah. Aaron, do you know if I'm wrong with that one?
No, I believe there's future plans to allow users to import their own 3D symbols, but at this point, if you've got a special request, reach out to our team. Our nimble development wizards might be able to help you out. Okay, couple more questions. I know we're already over time, so let's see if we can get through these. The next one kind of goes back to the LandXML question area. So with exporting a LandXML, in order to bring it into Civil 3D, will that import the alignment, the vertical profile, and the corridor also?
Yeah, so maybe I should, rather than just point, I'll go through the the next step of looking at that set of options. So file, save as, I'm gonna just say example. Land XML. All right, so this is the actual dialog you see when you do a land XML export. We've got our horizontal alignments. Now I've deleted that one that I just added in. So there's only the current, but if we had multiple, we could come in here and select whatever alignments we wanted to export. Corridor surfaces, we can hit include, and this will preserve the actual surface of the corridor that you have designed. You can add in additional surfaces. So right now it's just my final merge surface, but you can split out your subgrade, surfacing layers, etc. Cross sections will give you the cross sections along the alignment, and that'll be, again, include different surfaces, and then you can even mess around with points, how frequently those points get exported. I would go with everything for those. But yeah, it'll take it all if you want to export a land XML. It's a really nice format for compatibility, whether it's surveying compatibility or just compatibility with other softwares.
Awesome. Okay, we're going to go 3 more questions, then call it, because I know we are over time. The next question here is, can I check site stopping distance in RoadEng?
Yeah. So based off of just the vertical, let's go back here. So I've got design speed 60 km/h, K of 16. Just based off the vertical, it's calculating your site distance. And if we went the other way with it, we could say, well, I want to maintain that site distance, and it'll go and calculate what K value we'd like. The calculations for that, if you click the help files for the vertical curves, it'll give you the actual formula used. But your inputs like deceleration rates and eye height and whatnot are in the road class specifications table. And another thing that you can save so you're not redoing it every time. If you want more of a visual approach for things, so if I just set my cursor there and go to drive by fly mode, I could I could jump to station 375 if I wanted to. And I could go in here and I could set options. So if I want to have a target, I can set that whatever distance I'd like. Let's go 50, and there we are. We can see that, and we can step through the alignment and look at, well, if there's anywhere along the way that disappears. So with that, if you've got really steep cut slopes and whatnot, and actually want to see it relative to the overall corridor surface rather than just the vertical like we have here, this is a nice feature for that as well. So yes, with 2 different methods.
Perfect. Okay. The next question says, will you be able to start and end a curve in line work that you import? I'm not sure if I fully get that one. And Matt, if you need me to ask the question asker more questions about it, let me know. I can repeat that one more time. It says, will you be able to start and end a curve in line work that you import?
I don't know. So if it's nice tangents, you can. For something like this, where we ran that polyline to alignment with curves, it'll search for the best solution. It might not find the optimal solution, but it'll get pretty close typically. Yeah, generally, yeah, I guess I'm not sure. Yeah, I'm not sure I understand the question completely. I think so.
It's the downside of answering the question when we've moved past the section that it was asked in. So yeah, apologies to the question asker. We unfortunately don't get to these in real time. If you want to add anything into the comment section, you can. We can certainly come back and readdress it. If not, final question, and then we'll wrap it up. I know we are over time, which is, can you design an intersection with this program, or is there an easy way to connect the roads accurately?
Yep. So connecting roads, we've, I guess in version 11, we've added snapping. Just a sec. Well, snapping to other alignments. Snapping to train features has been in there for a long time. But with that, we can jump around and it's going to snap to the location that we click it. Intersections, it's not just a click a button and gives you the solution you like, but there's a few different methods to tackle it, and they can be real simple and coarse if you want real simple and coarse, or if you want something more robust that'll account for the twist of your road if you're intersecting on a steep grade or something like that. There's flexibility to account for that as well. Yeah, it's a bit more than a explanation in the last couple of minutes. So for that person, we can send you a video and yeah, touch base.
Perfect. And with that, thank you everyone for staying with us an extra 10 minutes. We are notoriously bad at estimating how long a webinar is going to take. Sometimes we're short, sometimes we're over, but we were really happy to have you all here today. We look forward to sharing this webinar up onto our YouTube channel in the near future. And we'll see you all for other upcoming webinars that are on the calendar. Have an awesome rest of your day.
Cool. Thanks, everyone.